video, we are going to know how to find the inverse of a 2 by 2 matrix. And if we consider a matrix A, which has the elements A, B, C, and D, then for us to be able to find the inverse of this matrix, we must find the determinant of the matrix. And that's why in our previous video, we learned on how to find the determinant of a 2 by 2 matrix. So the determinant of this 2 by 2 matrix will be given as the product of the primary diagonal, which sometimes we call it the leading diagonal, and we subtract the product of the secondary diagonal, which is AD minus CB. Now we have the determinant. So with the determinant, how do we proceed? So the moment you get the determinant, you proceed to find the inverse. So to find the inverse of this matrix, sometimes written as A inverse, so that is A power -1. That is how we denote the inverse of a 2 by 2 or the inverse of any matrix. So we are going to take the reciprocal of the determinant. So this is the determinant that we got. So the reciprocal of the determinant, we multiply that by the matrix, but we interchange some elements in this matrix. And how do we go about it? So for the leading diagonal, we interchange the elements. For instance, you notice that in this case, we have D here as the last element, but now it is the first element in this matrix, in the new matrix that we are going to multiply with the inverse of our determinant. So that means we interchange the values for the leading diagonal, and for the secondary diagonal, we change the sign. So if this was a positive, you notice it's a positive, we have it as a negative. If this is a positive, we have it as a positive. So that means if this was a negative, it's going to be a positive when we write it in this case. So here, therefore, we're going to have the inverse of this matrix is equals to 1 over the determinant is AD minus CB, and we multiply that by, we interchange the numbers here. So instead of A, we're going to have D, and instead of D, we're going to have A here. And for this one, since it's a positive here, then we're going to have a negative C, and this is going to be a negative B. And that's how we can find the inverse of a 2 by 2 matrix. As an example, let us find the determinant. We are supposed to find not the determinant, but the inverse of this matrix. So let us find the inverse of this matrix. For us to find the inverse, we must find the determinant first. Now the determinant, therefore, is going to be equal to the product of the leading diagonal, which is 6, multiplied by -3. And we subtract that, -4 multiplied by 8. This is going to be equal to -18. Now, minus 32. Minus 32. And of course, we have a negative here. So that is going to be equal to -18 plus 32, which is, I think, 14. 14. Now, so with the inverse now, with the determinant now, this is the determinant, we can proceed to find the inverse. So the inverse of A, written as A raised to -1, is equals to 1 over the determinant, which is 14. Multiply that by, we interchange these numbers, these elements. So instead of 6, we're going to have -3, and instead of -3, we're going to have 6. And of course, we change the signs for the secondary diagonal. So instead of -4, we have +4, and instead of 8, we have -8. So let's go ahead and simplify. So if we simplify this matrix, we're going to have, let me use this room over here. We're going to have -3 over 14, -3 over 14, and then -8 over Of course, we can simplify that. That's going to be negative 4 over 7. Negative 4 over 7. This is going to be 2 over 7. And of course, here, if we simplify that, it's going to be 3 over 7. And that becomes the inverse of our matrix here. Again, if you have a matrix, you must find the determinant if you want to find its inverse. After you find the determinant, you find the reciprocal of the determinant. And then you multiply it with the matrix, but now you interchange the elements. For example, the leading diagonal, you interchange the numbers, and in the secondary diagonal, you change the signs. And of course, we have done an example with 6, 8, negative 4, and negative 3 as our matrix, and now we have found the inverse as negative 3 over 14, negative 4 over 7, 2 over 7, and the 3 over 7 as our inverse. And that's how it's done.